So here's what our agenda is. It's not too aggressive. You've got your test on what is this? The third unit is on Tuesday. Okay, so that test involves the 3 sections from chapter 7, none of which were super long. There was the metric prefixes. There was the second section, which was basically that one little chart of the conversions between the different forms of liters and the cubic units. Okay, so remember, you got to find the volume of a box. The question I ask you on the test is going to be just like the question I asked you in class. So go back and review the 2 or 3 of those we did. And then in 7.4, we did dimensional analysis, and there'll be several questions on that. And then we talked in section 8.1. We've done some basic geometry stuff. We're going to finish that out now. And then 8.2 just kind of continues talking about angles and some interesting problems to solve there. So that's going to be the test that you've got coming up on Tuesday. So here we go. Let's finish off section 8.1. My camera's got me way over here today, and a little off center. So yes. I don't like watching myself because I see how, like, I know I'm bald, I get it, but I can see it now, and it's like, I told my wife in the summer when I don't have to be around people, I think I'm going to try to shave it and going for it and seeing what happens. That's on camera now. What am I doing? Why did I tell that? Why am I going to post this on YouTube? Oh man. Okay, it's okay. It's okay. All right. So now I got to get myself centered again and get back. Okay. So where we ended last time was with this topic. So the last thing from section 8.1 is about parallel lines. Does anyone know what makes 2 lines parallel? What that word means? They don't intersect, yes. So they stay the same distance apart, like hopefully train tracks do. And if not, then you don't want to be on that train. So parallel lines are 2 lines in the same plane. I'm just going to add that detail. 2 lines in the same plane. Yep, that do not intersect. So then there's some relationships among the angles in our parallel lines that is going to kind of be our focus. So let me just draw 2 parallel lines. So it looks like a big equal sign that I'm drawing right here. And those 2 lines, we're going to assume that they never intersect. Sometimes when you're doing problems in the book, they will label these lines, like I'll call this one line L and this one line M. It doesn't matter what letters you use. Okay, so those 2 lines are parallel. They never intersect. They always stay the same distance apart. It's not essential. It's not a vocabulary test. There's a few things that you have to remember. This is called a transversal. You don't need to remember that, but math people label everything. Okay, so transversal is a line that goes through 2 parallel lines. So it looks like I got a big not equals sign on the board. So what I've created is several pairs of angles here that have a relationship since the lines are parallel, and we're going to focus on those relationships. So just so that we can easily refer to all of these angles, I'm just going to number them. So I'm just going to start at the top, and this one's 1 and 2 and 3 and 4, and then 5, 6, 7, 8. So I'm just labeling those angles so that we can refer to them nice and quickly. Yes, this is geometry. This is what I've been talking about. I know last time you said that you were having a traumatic experience, but hopefully we're feeling a little better because I just admitted my baldness and my desire to shave my head on the camera. So hopefully that loosened us up all just enough. So we got the transversal. So there are several different pairs of angles that we're going to look at. Now, this first pair of angle is not exclusive to parallel lines, but I haven't mentioned them till now, and I'm going to mention them. If 2 angles are across from each other on a vertex, if 2 angles are across from each other, they're called vertical angles, and they're equal. So angle 1 and angle 4 are what's called vertical angles. They share a vertex. They're right across from each other. So just to help reinforce that concept and recognizing what it is, what's another pair of vertical angles on my diagram right there? Not 5 and 6. 5 and 6 are right next to each other. Okay, 5 and 6 would be supplementary angles. They add up to 180 degrees. 5 and 8, yes, 5 and 8. Great. What else? Angle 2 and angle 3. Yes, and there's one more pair since we're going for them all. Yep. All of those are what's called vertical angles. They're equal to each other. So angle 1 is equal to angle 4, 3 is equal to 2, 5 and 8, 7 and 6. So again, that's not exclusive to parallel lines, but I just wanted to mention it and get that out in the open. Now, the things that are exclusive to parallel lines. So for instance, angle 1 and angle 5, they are called corresponding angles. They're called corresponding angles because they're in the same part of, like if we consider each of these, angle 1 is the top left of the transversal and angle 5 is the top left of the transversal. They're in corresponding spots. Okay, so right here. So again, just to write down the other pairs to help us in identifying them. If angle 1 and angle 5 are called corresponding angles, what other angles here would be corresponding angles? 3 and 7. Okay, 3 and 7. Great. What else? What'd you say? Did you say 2? Okay, great. I just couldn't hear because I've got a lot of problems today. Angle 2 and angle 6, yes. And then there's one more pair of corresponding angles. Yep, that is it. Corresponding angles are in the same position and they are equal. So angle 1 is equal to angle 5, 3 is equal to 7, 2 is equal to 6, 4 is equal to 8. So those are equal. Vertical angles are equal to each other. Corresponding angles are equal to each other. We've got 2 more types of angles. I'm going to erase these. So are we good? Is everyone caught up? We feeling okay? I'll just do the top then. Can I do the top part? Okay. We'll take this in phases then. Okay, the next type of angle is called an alternating, alternate interior angles. Oh, alternate. So alternate interior angles, remember math people don't label things in a creative way. Math people are very descriptive. So just follow along with the words. Alternate means it alternates sides of the transversal. Interior means it's on the inside of the parallel lines. So I'm going to give you one pair of alternate interior angles, and you're going to give me the other. So 3 and 6 are alternate interior angles. They make like a Z. I think this a little darker. Alternate interior angles make like a little Z. So I've got 3 and 6 are alternate interior angles. So angle 3 and angle 6. Alternate interior angles are equal. There's another pair of alternate interior angles. What are those? Yep, 4 and 5. They swap sides of the transversal. They're on alternate sides of the transversal, and they're on the inside of the parallel lines. That's why they're called alternate interior angles. Then one more. And we're done writing things down for 8-1, and then we're just going to work a problem, and then we will be done with this section. So the last thing is, if I have alternate interior angles, then I have alternate exterior. So anyone want to hazard a guess? Okay, I've showed you what alternate interior angles are. We've defined the pairs. Anyone want to pick a pair of angles that you think might be alternate exterior angles? Yeah, perfect. Again, alternate means they alternate sides of the transversal. One's on the left side, one's on the right side. And then exterior means they are on the outside of the parallel lines. Now, so that would be angle 1 and angle 8. And then what's the other pair? If 1 and 8 are alternate exterior, the other pair is what? Great. Okay, so here's the problem that we have to to reinforce this sort of thing. So I'm going to, well, I'm not going to erase all the numbers. I'm just going to draw a whole new thing. You don't have to. I just messed mine up. So I'm going to draw basically the same thing. So here's a parallel line. Here's another parallel line. Here's my transversal. Okay, and then I got all my angles here. So what I'm going to do is I'm going to define the measure of one of the angles, and then using all the trivia that we've just had since we got here, we are then going to fill in the rest of the blanks. Okay, so for instance, I'm going to tell us that this angle right here is, let's say that that is 42 degrees. Then I'm going to number the rest of the angles. So this will be 1 and 2 and 3, and then that one's 42, so I'm not going to number it, and then 5 and 6 and 7 and 8. Okay, I'm just numbering it in the same way that I numbered the previous figure. Okay, so I've got my two parallel lines, got my transversal, and what you're going to do is you're going to tell me the measure of another angle, and you're also going to tell me why it is what it is, like how it relates to the 42-degree angle. So who wants to give me one? Okay, so angle 1, the measure, remember M, the measure of angle 1 is 42 degrees, and then they are across from each other. What's the specific, I know you know, you got it, but I just want the specific word. What's the word for when angles are opposite each other like this? Vertical. Okay, measure of angle 1 is 42 because it's vertical. It's a vertical angle, great. So let's fill that in. The more of these we do, the more reasons there are for each angle measure, because you got more to compare them to. Okay, what else do I know? We might need to draw on a little bit of our knowledge from last time. Hopefully you remember a little bit of that. Okay, it would be. Why did you get that? Explain to anybody who is not seeing. Why is angle 2 138 degrees? They're supplementary. Yes, I get those backwards all the time too. Complementary angles add up to 90, okay, and supplementary angles add up to 180 degrees. You could also say that angle 1 and angle 2, they form a straight line, which is 180 degrees, which is what it means to be supplementary, which sometimes I can't say that if I say it too many times in a row. Okay, so the measure of angle 2 is 138 degrees, and the reason is it's supplementary with angle 1 or with the 42-degree angle. It doesn't matter which one you compare it to. What else?
The bottom is just the same as the top.
Why? Tell me an angle and let's determine a reason. You're totally right. You're 100% right. You're seeing it. I want to practice the reasons.
So angle 5 is 42 degrees.
Okay, why is angle 5 42 degrees? There's two reasons you could pick here.
Because it's vertical? No.
It's not vertical, but it is, somebody said alternate interior. Okay, it alternates the side of the transversal. It's on the inside of the parallel lines. Another correct answer would have been to say it corresponds to angle 1. They're in the corresponding position, so they would be the same. Either way of determining it. So the measure of angle 5 is 42, and I'm just going to write the first thing that I heard. It's alternating interior with the 42-degree angle. Okay, great. So there's multiple reasons for many of these angles. Again, the more of them we define, the more reasons. How about angle 8? What's angle 8 going to be equal to? 42, and there's 3 reasons that you could pick to justify that. Okay, you could say angle 8 is 42 degrees because it's vertical with angle 5. You could say angle 8 is 42 degrees because it corresponds to the original angle we know. You could also use this justification, angle 8 is 42 degrees because it's alternating exterior with angle 1. Doesn't matter which one. It's all equivalent. It's just whatever one you see. Different people, brains work differently, see different things. I'm just going to keep labeling the figure and save the time of writing this out. I think hopefully we're catching on. Give me another angle and what it's going to be. Sure, bring it.
Would angle 7 be the same as angle 2?
It sure would. Why?
Because wouldn't it also have to
Woo, yes, it is alternate exterior. Beautiful. Celebrate. Yes, it's alternate. I'm only going with what I know. If we did know this, yes, it's vertical with that. So if you went in a different order, like I said, there's lots of different paths to the same destination. But since this is the one that we know, it's alternate exterior. Perfect. I'm going to give you credit for this one. 6 is vertical. 6 is vertical with 7, so it's 138. And then angle 3, we see it. I'm sure you see that it's 138 degrees, and there's 3 reasons. It's vertical with 2, that could be the reason you pick. It's alternating interior with 6, that could be the reason you pick. Or it is corresponding with 7, okay? The justification, there's many different ways you can do that. Okay. We good? We okay? Yes, sir.
How is this question going to be laid out on the test?
You know what? Just because I enjoy you, I'm going to tell you exactly how I'm going to do this on the test. Okay? You know how we started it right here?
Yes.
That's exactly the question I'm going to ask on the test. I'm going to give you an angle and I'm going to say, fill in the rest.
What is wavelength? That,
Mhm.
we're gonna have to explain why.
I'll have a different question where you're going to tell me what these 2 angles are. So you do need to be aware of those words, the corresponding and I'm going to give you the choices. It's nothing's fill in the blank. Okay, so there's choices. I always enjoyed that more because I couldn't spell anyway. So, but you do need to be aware of the different relationships. Yes, that's why these 2 sections, these 2 units, Unit C and Unit D, are short. Is because even though there's not a lot, it's intensive on things that you kind of have to remember a little bit, okay? And I try to keep that to a minimum. Okay, great. So we are now done with section 8.1 with our discussion, our presentation of parallel lines. So let me stop this video. And then we will start a new one for 8.2.